All right, in this video, I'm going to be talking words. How do you use them? I don't know. Talking about the sum and difference identities, 5.4. You will be given this sheet. This sheet I have folded. It'll say pre-calculus trigonometry identity sheet, and there are a bunch of them. Yay, yay. The ones right in the middle, these are your sum and difference ones. Sum and difference, if you sum something, you add something together. So you're adding angles. Difference is subtracting angles. So you're also subtracting angles there. Words, yes. Okay, but the way that you are going to read this sheet is check out with sine. Sine of u plus or minus v equals sine u cosine v plus or minus sine v cosine u. Notice the pluses are on top here. So if you have sine of some angle plus some other angle, you are going to use the sine on top over here. So sine u cosine v plus sine v cosine u. All right, and then notice with tangent or even cosine, it has ones that are flipped. So that one has a minus over a plus. All that means is if you have cosine of u, say we have minus v, so if we see cosine of some angle minus some angle, since the minus is on bottom, I'm going to use the sign on bottom over there, which is a positive. So this is the same thing as cosine u, cosine v, and then it will be plus sine u, sine v. Okay, we're going to be using these identities. You're going to have this sheet on your test, so make sure you don't write on it. As long as you don't write on it, we will be happy and we can use it on our test. Otherwise, you're kind of out of luck. All right, with this one, determine the value of sine of 75 degrees. I know that if I split this up in my reference angles, sine of 75 degrees is the same thing as saying sine of 30 degrees plus 45 degrees. Right, so it has to be 75. The reason why I picked these is these are both angles that we have on our unit circle, or they are both our reference angles. So they are both things that we can evaluate for the sine function. So using my sheet, I have sine of some angle plus some angle. So what I can say now is that I have sine of u. So that's acting as my u, that is acting as my v, so sine of 30 degrees. Cosine 45 degrees plus, since that is positive on top, sine 45 cosine 30. And then I'm just going to evaluate those functions exactly where they are. Okay, so again, if you don't know your unit circle, know it, or know the triangles. Either way, you got to know something. If you don't know something, you are going to fail this miserably, and I will not be happy, and you will not be happy, and just everybody's going to be sad. Okay, so sine of 30 degrees you can evaluate as 1/2. Cosine of 45 degrees is 1 over root 2, plus sine of 45 is 1 over root 2. Cosine of 30 is root 3 over 2. Okay, if you don't remember how to evaluate trig functions, go back and look at 4.3. Okay, then you can multiply 1 over 2 root 2 plus root 3 over 2 root 2. And then, I need a different color, you have 1 plus root 3 over 2 root 2. The book is going to rationalize this, and you may see some rationalized answers on your test. So in order to rationalize, you would have to multiply by root 2 over root 2. And then we will have 2 plus root 6 over 4, because square root 2 times square root 2 is just 2. 2 times 2 is 4. And there would be your solution. All right, I'm going to do another one kind of similar here. I don't know if I said it on the last problem or not. I'm sorry if I didn't. But what you're trying to do when you break up these angles, you want to have something that you can reference in your triangles or your unit circle. Do not pick angles outside of that. So like for 165, I can make this addition of 120 degrees and 45 degrees because I know 120 degrees has a reference angle of 60 degrees. 45 is just 45, so both of these are in my triangles. So now I can say this is cosine of 120 plus 45. There are other angles you can use. You don't have to use these two. There's other ways of doing this problem as well. But then I can use my identity. So I have cosine of 120, cosine 45, minus sine 120, sine 45. Okay, and that's just coming from the middle sheet. I have cosine of u plus v, so notice the plus is on top. So I'll use the sign on top on my right-hand side. Cosine u cosine v minus sine u sine v. And then I'm just going to evaluate those trig functions where they are. Again, if you don't remember how to evaluate trig functions, you have some serious catching up to do. You need to go back, watch section 4.3, 4.3. It's called unit circle. If you can't do this stuff, you are not going to do very well in this test. I warned you guys back in the video, and you're going to hear me warn you again that you need to learn this stuff, so make sure you learn this stuff. If you haven't learned this stuff, it's not such a terrible thing, but you need to go and learn this stuff. I can't help you if you don't know this stuff. So with this one, cosine of 120 degrees, that reference angle is 60, so from your 60 degrees, cosine is adjacent over hypotenuse, so 1 over 2. It will be negative since it is in the second quadrant. Cosine 45 is 1 over root 2 minus sine of 120, which is root 3 over 2. Sine 45 is 1 over root 2. Okay, again, if you can't do that, you need to be able to. So go back, watch the video. So you have negative 1 over 2 root 2 minus root 3 over 2 root 2. Since they have the same denominator, I can go ahead and combine them. So negative 1 minus root 3 over 2 root 2. Your book and the multiple choice on the test will rationalize this as square root 2 minus root 6 over 4. That is a negative right there. Negative root 2 minus 6 over 4. All right, in doing ones with radians, we're going to do the same thing. We're going to come up with some angles that we can use our reference angles with. So it's going to kind of be a little bit of a guess and check. If I try 5 pi over 12 plus 6 pi over 12, well, hey-oh, 6 divided by 12, that will reduce to pi over 2. But 5 over 12 does not reduce. I don't have that angle anywhere on my unit circle or my quadrants, so let's not use those angles. So let's try some other ones. What about 3 pi over 12 and 8 pi over 12. 3 plus 8 is 11. 3 divided by 12 will reduce to 1/4. 8 over 12 will reduce to 2/3. So hey-oh, both of those are on my unit circle. So I can say the same thing as cosine of 3 pi over 12 plus 8 pi over 12. So then I have cosine of pi over 4 plus 2 pi over 3. And then I'm going to use my identity. Since I have plus, I'm going to use minus in my identity. So cosine of pi over 4, cosine 2 pi over 3, minus sine of pi over 4, sine 2 pi over 3. And then from there, it's just a matter of evaluating your trig functions. Cannot stress to you enough, if you don't know how to do that, you are stuck right there and you are not getting very much credit. So you have 1 over root 2, cosine of 2 over 3, adjacent over hypotenuse, so that'll be 1 over 2. It's negative since it's in the second quadrant, minus sine of pi over 4 is 1 over root 2. Sine of 2 pi over 3 is root 3 over 2. Hey, I think I just did the same problem twice, maybe. I don't know. No, it's a little bit different. Well, no, it's not. So negative 1 minus root 3 over 2 root 2. The book will rationalize this, and the multiple choice on your test will rationalize this. Remember, rationalizing just means, oops, that's supposed to be a 4 down there. Just multiplying by the square root on the bottom, both top and bottom, distribute it, multiply, reduce, yay. All right, now with this one, we already have it such that it's written out for us. The only problem here is that angle 5 pi over 12 I don't have in my triangles or on my unit circle. So what I'm going to try to do is, since I know that I was going from this side to this side, what if I try to go backwards? And I'm going to see if that gives me an angle that I can work with. So I have u, I have v, I have u, I have v. This is plus. It is on the bottom, so I'm going to use the sign on the bottom on the left-hand side. So this will be cosine of u minus v, so 5 pi over 12 minus pi over 4. Right. Again, that is because of our identity. We have plus on the bottom here, right there, right there. And so when I rewrite it, I will use minus since that is on the bottom. I have u, u, v, u, v, u, v. So everything looks like it's lining up perfectly.
Perfectly! Oh, it's so pretty.
So then I need common denominators in order to subtract fractions. So if I multiply this one by 3 over 3 to get a common denominator, if you guys don't know what a common denominator is, holy cow. I love you guys, but wow. That's like 4th grade stuff. 3 pi over 12. So then I can subtract these. So cosine of 2 pi over 12, which is the same thing as cosine of pi over 6 when it reduces. Cosine of pi over 6 is root 3 over 2, and I have a solution. Whoa! Alright, kind of the same thing as the last one. I cannot evaluate tangent of 15 degrees, so I need to change this. But I noticed that 60 minus 15 is 45, and I have the minus on the bottom right there. The plus is on the bottom right there. So I will use the sign on the bottom over here, so tangent of u minus v. So if I do that, there's u, there's v. So tangent of 60 minus 15. I'm really bad at drawing 5s. I wonder why. I think I have 5-lexia. Tangent of 45 degrees, tangent of 45 degrees, opposite over adjacent is 1. Yay. And I know you guys love my background. There are all sorts of different monkeys. I'll show you another one here in a minute. Alright, so again, verify is proving that one side equals the other. Obviously, this is a cofunction identity, but if you see this and you're in this section of the book, you're going to want to verify it using your identities that we are talking about. So yes, I know this is a cofunction identity, but I'm going to verify it this way. So if I know I have u minus v, then I'm going to use sine of u, so sine of pi over 2, cosine x minus sine x cosine pi over 2 equals the other side. Well, now I can evaluate sine of pi over 2 and cosine of pi over 2. Sine of pi over 2 is 1, so I have 1 times cosine x minus sine x times cosine of pi over 2 is 0. 1 times cosine is just cosine. Sine times 0 is 0, so that whole thing is just equal to 0, so I have cosine equals cosine. See? Not too bad. Alright, same sort of deal here. But I don't know that this is a cofunction, so I don't know for sure this is going to come out cosine. Obviously, hopefully it will. If it's asking us to verify, it already knows that it is, and we can obviously see that that's a coterminal angle, so it will be, but we still have to prove it. So if I have u plus v, I know it's cosine, so I'm going to do minus in the middle. So cosine of u, cosine v, minus sine u, sine v, equals. Cosine of 2 pi is 1. 1 times cosine theta minus sine of 2 pi is 0. So 0 sine v. Again, 0 times anything is still 0. Right? Back to 3rd grade. Just keep moving backwards. So then you have cosine theta equals cosine theta. Happy day. Uno más para ti. Alright, this one's fun. I like this one. Oh no. So you have cosine of some angle plus some angle. So that's cosine of u plus v. And then, oh! I get to go home. Well, bye! Nah, just kidding. You know, I'm just kidding. So with this, and then sine of u plus v. So this one, make sure you use the minus. So cosine of pi over 2 cosine x minus sine pi over 2 sine x. There's a minus in the middle. Now it's a matter of doing this one. So sine u cosine v plus sine, I need to make sure I put this in parentheses, sine x equals 0. Oh no, I forgot to write it. Sine x, put right there, cosine pi over 2. I forgot to finish the identity, I'm sorry. My bad. Okay, so you'll have cosine of pi over 2. You can go through and evaluate all of these. Cosine of pi over 2 is 0. So 0 times cosine, that'll just be 0. Cosine of pi over 2 is 0, so that'll be 0. Sine over pi over 2 is 1. Sine of pi over 2 is 1. So I have negative sine x minus cosine x equals 0. Well, then from there, it's just like what we were doing in 5.3. So if I make this negative sine x equals cosine x, if you see it from here, then you can say 3 pi over 4 and 7 pi over 4, and I am happy. If you don't, you need to go through and square both sides. Make sure you check your solutions in the end. So this will be sine squared x equals cosine squared x. Sine squared x I know is 1 minus cosine squared by my Pythagorean identity. And I'm just so smart. Oh! Not really. I just studied. Cosine squared. Then you can divide by 2, so you have 1/2 equals cosine squared. And then you can take the square root. Yay, yay. So I have cosine x equals plus or minus 1 over root 2. Well, if it's the 1 over root 2s, that's going to happen at all of our pi over 4s. So x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, just make sure you go through, plug them back into your original function where you see your x values. If they do not work, if they do not equal 0 altogether, they are not a solution. You will find that pi over 4 and 5 pi over 4 do not work. So you only have 3 pi over 4 and 7 pi over 4 solutions. Hopefully this video helped you guys out. Make sure you come ask me questions. Write down your questions so you can remember to ask them to me. If you don't ask questions, then I assume you know it. So make sure you ask questions. If you don't, I don't really feel that bad for you. Bye-bye! Boo!